6 times pi, which is 12 pi. The only thing I'm missing, if this was like 6 centimeters was the radius, then this would be centimeters squared, and this would be centimeters. Area has the squared, all right? And then 22 out of 70. Just divide it out. 22 divided by 70 is just a little bit over, is just over 31. So this is about 0.314, so 31.4%, okay? In context, 31% might be good, might be bad, but we're going to take the concept of finding area, finding this percentage, and merging them together. There's that. All right, so here we go. We have our circle. Think of a pizza. Had pizza last night. It was awesome, all right? So this is the circumference, all right? That whole distance all the way around is called the circumference. And what we're doing with arc length now is we're going to talk about our central angle. And now we're only going to talk about a portion of our circumference here, okay? We're going to be talking about just the circumference from one part of the arc that's been intercepted by the radius all the way to the other spot, okay? And how we're going to do that is we're going to find the circumference just like we did in a warm-up, but now we're going to find a percentage. We're going to find out how much of 360, because a full circle is 360 degrees, so we're going to find out how much of 360 we are going to go around, and then we're going to find that percentage and then take that percentage of the entire circumference, okay? So M is going to stand for the arc or central angle measure. Okay. Likewise, we're going to do the same thing with area of a sector. Okay. Sector is just, again, a section, right? A section of a circle. So now the area of the sector is how much space are we covering right here. So we're going to find a percentage of the area of a circle. So we're going to do the same thing, pi r squared times the percentage, right? So how much of 360 are we taking up? And we're going to take and we're going to multiply that by pi r squared. Okay, so that's going to be our goal. And then we're going to work backwards. Right, they're going to give us the area of the sector, and we might have to work backwards to find out the radius or how many degrees is the central, how big is the central angle, that kind of stuff. So let's roll through here. Find the length of EF. So we are going to take and find out the circumference, 2 pi r, which is 12 pi. And then we're going to find out our percentage, 120 over 360, which is 1/3. Then you multiply 12 pi times 1/3, which is 4 pi. Remember, when you're multiplying fractions, if you reduce your fraction, it's just top times the top. So 12 times 1 is 12. So this would be 12 pi over 1 times 3, which is 3, and then 12 divided by 3 is 4. So we're going to do 4 pi meters. I'll show you a different way to do the math on the second one here, right? Diameter is 24, so circumference is equal to pi times diameter as well. So we're going to just go 24 pi. Find our percentage, 6 over 360. If you don't want to reduce the fraction down, really what we're doing is doing a little Desmos here. We'll do 60 divided by 360. That's our decimal. And then we're going to multiply that by 24, which in this case, it gets us 4 again, right? So when we just multiply this whole thing out, it gets us 4 pi. And then it doesn't give, it does give us centimeters there, okay? Now we're going to see a circle has an arc of 80. So we got 80 over 360. They give us how much of the whole we want, and whose arc length is 276.46 pi. We want the diameter. Well, we know circumference is pi times the diameter. We're going to set that equal to 276.46. Oh, and don't forget about that pi. That pi is right there, okay? Now, we have to solve for d here. Well, good thing is there's pi on both sides. Whoops. And how do I get rid of this fraction? Well, I'm multiplying by 80, so I'd have to divide by 80, dividing by 360, so I'd have to multiply by 360. So anytime we're multiplying by a fraction, to get rid of it, we could say multiply by the reciprocal, which is the reciprocal is just the flipping of a fraction. You invert it. And then these all cross out, and then we get d is equal to. And then now I'm just going to do, again, multiplying by fractions, top times top, and bottom times bottom, or use Desmos here. And we're doing 276.46 times 360 divided by 80, which gives me 1,243.93. What was it? 43.93 pi, and then inches. No, it's not pi. We crossed out the pi. Thinking of the last question. So our diameter is 1,243 inches. Okay? This next one, find the measure of the central angle. So we got to find m, right? It's saying what's the measure of the central angle. So we're finding m. We're going to have m over 360. So when I get m by itself, I'm going to have to multiply by that 360. It gives us 3.98 as the arc length, pi, equals the radius, which is 18. So we're going to do 2 times 18 times pi, 2 pi r. So we get 36 pi m and 360. So again, practice solving. Cancel out the pi's. And then I'm going to just do 2 steps here in case some of you like to see the different steps. 3.98 divided by 36 gives us 0.1105, and then that 5 is repeating, and we have m over 360. So then I'm just going to take that number that's in my calculator, multiply it by 360, because I'm dividing by 360, and then we get m to equal 39.8 degrees, or if we round it up to 40 degrees. Right, so that's dealing with arc length. And now since we're multiplying, right, and all of our values, there's no expression that's like x plus 3 is the length of something. Since our formula is all multiplying, now we go back up to this formula here, we're all multiplying and or dividing right here. We're dividing by 360. So when we're solving for either r or the m, or in this case, the x value up here, we're going to have to multiply and divide to solve algebraically, okay? When we get to this arc length, we're dividing, multiplying here, and then how do I get rid of the square? Do you remember how to get rid of a square? So when we did the Pythagorean theorem, we had c squared is equal to 20. How do we find that out? We took the square root. Good job. We're going to be doing the same thing if we have to solve for the radius today. All right, let's calculate the sector area below. We are going to do pi r squared. So 16 squared times pi is 256 pi. Then we're going to do 120 over 360, which again is our 1/3. So taking a third of 256, which is 85.3, repeating pi, and now we're in area meters squared. You could just type it all into Desmos or your calculator that you have and get a decimal, like 85.3. Okay? Circle has a radius of 12. Find the area of the sector. So again, this is the same thing. 12 squared times pi. 120 over 360 is our 1/3. And then 1/3 of 144 is 48. So this would be 48 pi inches squared. All right, so we got to do 2 things. It says area of the circle is 225 pi. So that's going to be equal to pi r squared. We want to solve for r and then use that in our formula to find out the percentage or the area of that sector. So I'm going to cross out the pi's. We have r squared equal to 225, so we're going to take the square root. Square root of 225, you go with your perfect squares, you know it's 15. Now we're going to use 15 as our radius. Actually, I think it's probably doing too much work, but that's cool. I'll show you. That's going backwards to find r, right? We don't have to do that here. I misread. This is silly of me. Because we have the area already. Whoopsies. We have the area already. And then now we want to find the percentage of it. So we just have to take the area and multiply it by the fraction. Again, if you are... Oh no, this is sector area. If you are doing this in Desmos, you can just type 225 times 45 divided by 360 in there, or you could do top times the top. Think of it over 1, right? So we're going to do 225 times 45 over 360, which is 28.125. So this would be 28.125 times pi, and then square inches. So we didn't need to find r, but that's good practice in case we had to go backwards and find r. We have to take the square root. Okay. Find the measure of the central angle. So now we're finding m again. And it gives us area, sector area. So this is how I know to use pi r squared versus the 2 pi r. And then the radius is 6, so this is going to be 6 squared, which is 36 pi. And now we just go through and do the steps we did before. It's just like the last question. All right, we're going to divide both sides by 36. .4361 repeating equals to m over 360. So again, we're going to multiply by 360. We get m is equal to 157 degrees.
Mr. Lundberg, 3702, please.
Thank gosh that's not for me. All right, so again, when we're doing area of sector, we're thinking area of a circle, we're finding the percentage of that area. If it's arc length, we are finding the percentage of the circumference. All right, good luck.